Welcome back. We are now looking at chapter 8. In this chapter we will only cover section 8.1 and 8.4, and from this chapter we are going to start something called inferential statistics. In the chapters 2 and 3 we used descriptive statistics when we summarize the data using graphs and statistics such as the mean and the standard deviation. This 8th chapter and the following chapters, we are not covering chapter 9 and we are not covering chapter 11, but they also include. So from 8 until 12 they are all using inferential statistics. So what does inferential statistics do, and what is the difference between these? We learned it in chapter 1. So here once again I wrote the definition. So descriptive statistics, basically it summarizes and describes the data that we get from samples. Inferential statistics, it uses the data to make predictions and draw conclusions about a large population. So what are the major activities of the inferential statistics which we will see? So number 1, use sample data to estimate the values of population parameters. So what are the parameters? Remember, they could be anything, but the ones that we are going to do is population mean and population proportion. So and the second activity or second thing it does, the inferential statistics, it tests hypotheses or claims made about population parameters. So, but that is something we will do in chapter 10. So let us now look at some important factors or important concepts that we will need and we'll try to understand. One thing we will see is something called critical values that is going to be used in this chapter, so and later chapters as well. So what are critical values? These are basically z-scores and are denoted by z alpha over 2 where z alpha over 2 denotes the z-score with an area of alpha over 2 to the right. So then it says, for example, if alpha is equal to 0.05. So notice here we did these type of values questions before in chapter 7. So this is negative z and this is z, and we know that the area over here and here combined area is alpha. Okay. So alpha is equal to 0.05. What does that mean? Now this will be 1 minus alpha, so this will become 0.95. And alpha is 0.05. So we want to find the z-score such that the area to the right of it is alpha over 2. So that this area is 0.025. So that we say z alpha over 2, which is equal to z of 0.025 will be equal to 1.96. How did I get 1.96? Go look at the table. So this is going backwards, not from z to area, but from area to find the z. So z will come out to be 1.96. Of course, then negative z will be negative 1.96, but we don't need that. We just need the positive z value. And this can be calculated for any alpha. So if alpha is 0.1, then it means this area will be together will be 0.1, but alpha over 2 will be 0.05. So you can figure out what Z alpha over 2 is. It means it's area to the right of Z alpha over 2 should be 0.05. Okay, so this in this chapter, as we said, we are going to use or see methods for using a sample mean to make an inference about the value of the corresponding population parameter. Actually, sample statistics. To make an inference about the value of the corresponding population parameter. So here are the three main concepts included in this section. What is a point estimate, how to construct confidence intervals, and how to find the minimum sample size for a certain hypothesis test to be done. So the main thing is the confidence interval. There is some key concepts or some related terms which help us understand the confidence interval and to construct the confidence interval. So let us look at those. So first one is the point estimate. So what is a point estimate? It is a single number estimate of a population parameter. So a single value that can estimate the population parameter. So for example, a single mean of a sample or proportion of a sample. What is an unbiased estimator? It is a point estimator that does not consistently underestimate or overestimate the population parameter. So it is a value. It is a point estimate is again single value that is basically a good estimate of the population parameter. Now it has been observed that X bar is an unbiased estimator of mu, and similarly P hat is an unbiased estimator of P. So what is X bar? That is the average or the mean of a sample, and what is mu? That is the mean of the population. So if we have some value, if we are looking at the sample of bags of chips. So if you randomly picked 10 bags of chips and looked at or measured the weighed them, and the mean weight was coming out to be 1.7 ounces, then what will we say, what is the mean of the, or what is a good estimator for the mean of the population of all these sandwich bags that are being prepared in the factory? So we say that the X bar 1.7 is a good estimator, is the best estimator actually. And then in the same way for P, for the proportion, so the sample proportion will be the best estimator of the population proportion. So, but we often do not rely on a single point estimator, because that we cannot see or we cannot understand how good it is, how how good the estimate is, right? So what do? That's why we look at confidence intervals. So the thing is, why do we need confidence intervals? Again, the reason is because the single estimator, the point estimator, which is a single estimator, single number estimator, it cannot tell us how well it estimates the sample, the population parameter. Okay, so now the next thing we looking at is unbiased interval estimator. So what is an interval estimator? It is a range of possible values for a population parameter. Okay. So going on. So what is confidence level? Confidence level is actually the probability 1 minus alpha of values that are used to estimate the true value of a good population parameter. Now the confidence level is denoted by C and can also be thought of as it is the percentage of all possible samples of a given size that will produce interval estimates that contain the actual parameter. So now what is a confidence interval? So confidence interval is an interval estimate. So it's an interval estimate associated with some level of significance. Level of confidence. Okay. So we are using these confidence intervals, which is next example. The next definition, confidence interval is a interval. So often we can write CI for that, is an interval estimate associated with a certain level of confidence. So one number or point estimate, we cannot rely on it, like how best it represents the population parameter. So that's why we look at confidence interval. So once we have the interval, it's very important to understand how to interpret the interval also. So what does it mean for a 95% confidence interval, or 80% confidence interval, or 85% or 90%, So these are some common levels of significance that I mentioned here. And now suppose this is a 90, actually this is a 95, 5 is missing from here. 95% confidence interval for the population proportion is given like this. So the lower bound is this one, and this is what we call the upper bound. So you can give the interval like this, or you can give it in the mathematical notation of interval, not including the endpoints. So you can write it like that. So there are different, there is only one correct interpretation, and then there are many incorrect. So just even in the, of course, in the correct interpretation, a little bit of wordings can change, but main idea or main gist of the definition is the same. So if we have a confidence interval, we could have any number here. So there is a correct interpretation, and then there are incorrect interpretations. So I have two incorrect interpretations here. So what is the correct one? So we say when we have created a confidence interval like this. Now we write the interpretation. Sometimes the question asks to interpret, sometimes it doesn't, but it's always a good idea to interpret. So if you have if you were given that construct a 95% confidence interval for P or for mu, so these are the only two parameters that you will be working with. So find a 95% confidence interval for the true proportions, for example. So if we find that our interval is this one, then we can say we are 95% confident that the interval from 0.828 to 0.872 actually does contain the true value of the population parameter P, or population proportion P. And if this was instead of a proportion, if you have the confidence interval for mu, so it could be like, for example, 25 is less than mu is less than 35. If this is a CI, if we have created a CI and it looked like this, so here, because it's a mean, so we will use the mu. This is not P, just as I want to tell you. Okay, so what is the correct interpretation? So we say we are 95% confident that the interval from 25 to 35 does contain the true value of the population mean mu. The incorrect interpretation, the first one, there is a 95% chance that the true value of P will fall between this number and this number. Well, this is actually not correct. Okay. Another incorrect interpretation, 95% of sample proportions will fall between, or in other words, 95%, 95% of the data will be within these numbers. So another way to understand the interpretation is from the figure below. So this is a 90% confidence interval. We have confidence intervals from 10 random samples. So these are 10 intervals. So for example, you can see the mean of the population mu is 29. And these are varying from between lowest is 25 and the upper limit is 33. So between 25 and 33 we can have bunch of these intervals, confidence intervals, and the ones which are related to your problem, if you pick them and let's say there were 10 of them, then at least 9 of them will show that the mu or the population mean lies in those 9 intervals. And we can see in the figure it is only not lying in the interval number 5, which is red. So because when we draw this horizontal line, mu is equal to 29, you see it is passing through every interval other than the 5th one. That's why we say that we would expect in the long run 9 out of the 10 intervals contain mu. And in this picture we see it's the number 5th. Okay, next thing that we will need to construct the confidence interval is the margin of error. So what is the margin of error? It is also called maximum error of the estimate, and we denote it by E, uppercase E. So this is the largest possible distance from the point estimate that a confidence interval will cover. And if you go back to this example, so see the number 7. So this looks like this is the largest. I don't know, maybe. So this will be the largest here, and then the same number we will go on the other side. So let's see now how do we do our problems. So in order to find the confidence interval, what are the steps? So the first step is to find the point estimate. Second step is to find the value of E, margin of error, and then we can get the lower level or lower bound of the interval by taking our point estimate and subtracting the E from the point estimate, and then the upper bound of the interval we will get by adding E to the point estimate. That will give us the upper and the lower bounds. So these are the steps. So it says find the point estimate for mu it will be x bar, for p it will be p hat. Look up the value of Z alpha over 2. So means look up the critical values. Okay. Remember, critical values are the Z values for confidence intervals given in the formula. Well, there is a table which gives those critical values and the corresponding Z alpha over 2. Now, how will you find E? Well, because next step is to find E. Find number 3. So it says find E, so subtract the point estimate, subtract E from the point estimate and add E to the point estimate. So, but we got the point estimate, now we need E in order to figure out what the confidence interval will be. And once we have done that, then we interpret our answer. So here is kind of the wordings that you will be using related to every problem you do. Here are the formulas for error and for writing the confidence interval. You can write it in interval notation like here, or as an inequality, set of inequalities like this. Okay, so probably this was just less than, not equal to, and same thing here. So this is the critical values for confidence intervals, and then we have this table, little table 8.1. This is also given in the formula sheet. Okay, I'll stop here, let you guys read and understand, and then I'll come back in next video to show you the solutions of some of the problems.